Okay, welcome. Haven't seen you guys in a while. I'm going to do a video for the law of sines, and there's a lot of stuff to cover, but we're going to try to make it quick here. All right, the law of sines, quick little recap. All right, we use the law of sines now when we're trying to solve an oblique triangle. Oblique no longer a right triangle. If we had the right triangle, of course, solving a right triangle is easy. We got the Pythagorean theorem. We have the regular trig functions. But when it's oblique, we cannot use those things. Okay. Now, in order to use the law of sines, it doesn't work on all oblique triangles, and we use it when we're given side angle angle, angle side angle, and there's also going to be the side side angle special case. Here's your law of sines. All right. Um, Now, they're the exact same thing, okay, but as kind of one of the special properties of proportions, you can flip a proportion upside down. You can even flip it side to side. But for the purpose of this equation, you can have everything where all the sides, the lengths, A, B, C, little a, B, C are on the top. All the angles, sine of A, sine of angle B, sine of C are on the bottom. Or you can flip it. And the reason we want the difference is just for ease of use. Okay, remember it's easiest and the best, of course, right, to solve proportions when whatever you want to solve for is on the top. Okay, it just makes things algebraically easier, and it saves you about a step or two each time. Okay, now in order to do this, right, we can do it if we know side angle angle. And looking at the diagram here, right, we got side angle angle, and the key thing to set up a proportion, right, is that we need to know one full proportion. So that way we have something that we can set the fraction equal to. Okay, so as long as we basically know any side and its opposite angle, or I should say any angle and its opposite side, then of course we could go ahead and use the law of sines. In this case, I would know both of the a's, I know one of the b's, I can solve for little b first. So that would be my setup. And again, remember, since I'm solving for little b, I'm going to set it up so that little b is on the top. And when I put in these, this is going to be an easy solve. Okay. Second case where we can use the law of sines, angle side angle. Now, if you just start with knowing the angle side angle, you may think that, I don't have any, angle and its opposite side. I don't have any angle and its opposite side. But with a little bit of thought, you do, right? Because with two angles, you simply find the third angle. If I know two angles, subtract those two from 180, and that's going to be the measure of the third angle. So once I find this one, I do have a third angle and the opposite side. And then just like side angle angle, I can use the law of sine. Okay, so the last part now is side-side angle. All right, so a lot of people, they giggle, they think of it backwards. That's ASS. Okay, a lot of people don't want to address it that way. Now, if I do have side-side angle, okay, we do have the opposite side and an angle. I should have drawn a picture, but I didn't. Okay, but this one's known as the ambiguous case. Okay, and I call it in my class, I call it ass backwards. All right, it's kind of actually the way I remember it. It's the one that you're not supposed to say, but at the same time, if something is kind of weird and funky, then we just call it ass backwards. Okay, so we'll look into that one into more detail here. Okay, so if you recall, now this was from the proof. Okay, and if you didn't get the proof, maybe that's something separate to look up here. But for as the proof, we use this partial diagram of a triangle, and the thing that we were missing that requires us to use the law of sines is the altitude, the height, a right angle. So we're going to go ahead and imagine that there is a right angle here, and I'm going to use the relationship, or the key relationship that makes the law of sines work, is the sine of A equals the opposite over the hypotenuse. Okay, now again, opposite and hypotenuse only exist in a right triangle. So if I rearrange that, I'm going to get this relationship. Okay, so specific to this triangle, it's going to be h equals b times sine of A. Now, of course, this is just to get used to it. This is just the conventional equation. Of course, when you're given, any random triangle, maybe your teacher might ask, use completely different letters. Make sure you understand the arrangement, and it's not always going to be labeled A, B, C, and H. All right, so we basically have these cases below here. Okay, now again, using these as a reference here. Okay, we look at the picture, and if this side here, A, is shorter than H, okay, hopefully you can see that it doesn't matter where this angle goes, I try to make it reach, I try to close this triangle. Well, if my altitude is longer than that, or basically this side is shorter, there's no way it's going to complete a triangle. Okay, so there's no possible triangle. When you plug this in using the law of sines on your calculator, okay, you will get an error message, and as long as you're comfortable plugging everything in, it's kind of a nice thing to see. When you see the error message, it just wasn't possible. Okay. The second scenario is if A equals H, well, there's only one way this formation can happen, and that is if A is the right angle. Okay. Anything shorter wouldn't complete the triangle. Anything longer, A would make a different angle other than a right angle. Okay. So when A equals H, only one triangle will be formed, and it will be a right triangle. You could do the law of sines. You can confirm your answers using Pythagorean theorem and normal sine and cosine calculations if you want. Okay, so the third situation here is if this opposite side A is longer than the known side B. Okay, hopefully you see that clearly this A, it can't be the altitude because it's too long to be the altitude, and this A can't go anywhere else. It can't, a lot of teachers like to kind of say it swings or hinges here. Because this A is longer than B, it would not be able to fit over here because B has to be the longest side in order to be the hypotenuse of this triangle here. Okay, so if A is greater than B, then A just has to go out there, and there's only one triangle possible, no other orientation possible. One triangle. Okay, so here's where it gets interesting. And there's two possible triangles, and this is what makes this SSA the ambiguous case. Okay, now when A, the length of A is between the length of the height and B, right? So H is there, H is my height. It's the smallest if I compare this leg, and here. Okay, now again, if A was the same as H, I would have one right triangle. But because A is a little bit longer than H, right, it could go out here, or it could also fold inside here. Now, whether it could fold inside here, remember, is whether or not A was smaller than B. Because if A is smaller than B, then yes, it could be any of these lengths in here. So A has to be smaller than B, but still has to be longer than H. A has to be smaller than B, but still larger than H. Okay, and if that's the case, I do have two things. So once you've decided that you could have two possibilities, all right, solving for it's not too bad. Okay, you're going to solve for B, you're going to set up the law of cosine, you're going to set up the law of sines, and when you solve, when you hit on your calculator inverse sine, there's one key thing to remember that actually makes this make sense. Okay, if you recall from the lesson on inverse sines, the inverse sine has to fall between negative pi half and pi half. All right, we should have learned that back in inverse trig functions. So because of that, right, obviously we're not going to get a negative angle measure, so therefore your calculator will only give you something between 0 and 90 degrees. Okay, and if it's only going to give you something between 0 and 90 degrees, that's an acute measure. So it doesn't matter which of these triangles you could have, or you are going to have both. The fact is, when you're solving for it and you use your calculator, this is the one that your calculator is going to show you. Okay, because again, whatever the calculator comes out with for angle B has to be an acute angle. All right, so as long as you recognize you're going to have both of these triangles, the other one, the obtuse angle B, is an easy find because the triangle that it's going to make is going to be an isosceles triangle right here. If you imagine isosceles triangle, right, kind of put these two together where you have an isosceles triangle, then whatever this angle B was has to match whatever this angle B is on this side. Well, then this and this together are supplementary angles, right? The obtuse angle measure B has to be supplementary. Of course, remember, supplementary means add them up. They add up to 180 degrees. Okay, so as long as you get this one, well, you simply subtract it from 180, and that's going to get you the other one. Okay, and that's the only way you're going to ever come up with this angle, because your calculator only knows to give you the acute angle when using the inverse sine function. Okay, everything after that, once you find it, you got two of your angles, you got enough for the law of sines, you can continue solving as normal. Okay, so there's going to be some examples. We'll save that for the end of the lesson here. Okay, but the next thing I wanted to address is another application or another thing that stems from the law of sines, and that's how to find the area of an oblique triangle. Okay, so if you remember this relationship here, okay, let's go ahead and draw this triangle here. Now again, we're using this consistent triangle here. And let's see, A, B, sine of H. So we have H, we call this one B, B, and side C, okay? Now again, we don't have a right triangle, so we technically don't have a height, but of course we can always drop an altitude to imagine one. If you use the regular equation for the area of a triangle, the original equation that we all know and love, area equals 1/2 base times height. Okay, and I'm not going to use B because I don't want to mix B up with side B. So base times height. I could just say H for height. Now if I look at this triangle here, specifically my area is going to equal 1/2. The base in this problem is C, and the height is H. Okay, now that doesn't look like a great formula, especially if we don't know what H is. So, right, we're using the law of sines. So how can I solve this, or how can I come up with an equation, a formula, that doesn't require H, but perhaps uses sine? We're going to make a simple substitution here. As long as we understand the relationship H can actually be found by doing B sine A, well, I'm going to replace H with B sine A. So when I replace H with B sine A, I have 1/2 times C, and here is B sine A. Okay, now that's the area, and that's specifically the area of this triangle here. Okay, so if I were to clean that up, I have the area equals 1/2 BC sine of A. All right, now it might seem like, oh, it's a little difficult to remember this. Okay, in just a second, I'll give you kind of an easy way to remember this. Okay, now the orientation, there's actually two other ways that this formula can be written, and it depends on kind of what you're given. Okay, now what you need to see if you kind of look at what we have is we have 1/2, right? We remember 1/2 from 1/2 base times height. You'll notice BC sine of A. Okay, BC sine of A is always going to refer to two sides that you know, and hopefully you remembered or you got the terminology, the angle between it, the intercepted angle. Okay, so it's always going to be two of the sides of the triangle and the angle in between, the intercepted angle. So for that reason, I can actually write the equation in three different ways. Right? I can also take area equals 1/2, and I can take two other sides. I can take BA, and the intercepted angle C. So AB and the intercepted angle C. Okay, and you'll see a pattern, hopefully. Usually the pattern's enough that once you see it, that's easy enough to remember. You'll see I use all three letters, A, B, and C. It's just one of them is going to be sine of the big letter, and then it's going to be the other two little letters, the sides. Okay, or if I just look at it here, complete what I was saying, it's going to be two sides and the intercepted angle. So AC sine of B. AC sine of B. Okay, now if that little pattern is not good enough for you to remember, right, as long as I have two sides and the intercepted angle, then what I usually come up with is a simple little picture. And this picture actually comes up later. I remember using it somewhere in my calculus class. But this is just kind of the way I remember this, right? I just look at the triangle, and then I take three circles. There's three possibilities. I make a circle with one angle and its two sides, right? I take another one, two sides and the intercepted angle. And then the last one is the angle, of course, that's intercepted by its two sides. Okay, so that's the three ways. It's not one set equation, it's just understanding 1/2 times the product of the two sides and the sine of the angle that's between the two angles, the intercepted angle. Okay, all right, so that's the lesson for law of sines. That should cover everything you need to know about the law of sines. But at the same time, right, we can also do a couple examples. So if you want, stick around for that. Okay. So how many triangles are possible here? Okay. Now, a picture is always good because remember that formula, you don't want to just plug things into the formula. You want to make sure that formula is applicable to what we're looking at. Okay, so let's do a quick picture here. 110 degree angle. 110 degree angle, and we'll call that A. And of course, remember, the angle is the large A, so the small a side has to be, of course, opposite the angle. C, I can make either one of these C, okay, but because we're tending to know the angle, the side, and the side, I'm going to go ahead and make this one 19 centimeters. So this one's going to be C. Okay, so if I'm going to go ahead and use the equation I know, I changed up the letters a little bit, but here's the test that I need. I need to know H equals, and it was B sine A, but in this case, right, so imagine that I have the height, it's going to be H equals C sine A. Okay, so go ahead and check your equation, and you'll see that it's C instead, right? It has to be the information I know. Yeah, of course, when we're using the law of sines. So I'm going to use my calculator for this here. Of course, when you're doing calculator work in a trigonometry, pre-cal, whatever class this is here, remember when you're doing triangle measurements, we should always be doing the triangle measurements in angles. Some classes, books, texts, they might be a little bit different here. Okay, so definitely check your mode and make sure you're in degrees. Okay, and let's go ahead and do this here. H equals C sine of A. Okay, so we got 19 sine of 110, and we get 17. Okay, why did I find the height? All right, so if you remember, right, we had kind of a comparison that we needed to look at. Let me go ahead and see if I can bring this back. Now, the picture is kind of more of an understanding if you can reason it, but right. So we have H, and we said A is 32. A is 32. Okay, so what happens when A is greater than H? When A is greater than H? Well, if A is greater than H, okay, and, is A greater than B, or is A greater than the middle side? Well, 32 is greater than 19, right? So in this case, A is also greater than C. So A is greater than C, and A is greater than H. Okay, this is the only triangle possible. And kind of without mentioning it earlier, if you have an obtuse angle, in this case of a triangle here, only one triangle is possible because I can't swing one of the sides anywhere else and still preserve this obtuse angle. Okay, so how many triangles are possible for this one here? Just one triangle. Okay, let's go ahead and try a second one here. All right, so again, let's draw this here. Measure of angle A, 68. So 68 is going to be an acute angle. Again, acute, so I definitely have to keep checking here. So it's 68. The opposite side is 9. Now, the important thing is you don't have to draw them to scale, but I'll try just a little bit. And C is going to be 34. Okay, hopefully you can see what's kind of going to happen, right? If you imagine I have a 34-meter line here and only a 9, that doesn't seem like it's going to complete, but let's just go ahead and check that just to make sure. So we're going to calculate what this H is. H in this one here is going to be these two right here, right? So it's going to be, again, C sine of A in this picture. So H is going to be 34 sine of 68. All right, I don't like where that one's going. 34 sine of 68. Okay, 31. H equals 31.52. Okay, so if I were to think of this here as 31.52, right, we have this case here where A is less than H, right? A was 9 meters. So what happens when A is less than H? Well, if A is less than H, right, just like this picture here, it won't close, no triangle can be formed, so there's no triangle possible. Okay, so no triangle. Somehow no came out 0. All right, so we saw 0, we saw 1. Let's see what happens in this last one here. Okay, I changed up the letters. A is a 47-degree angle. B side B was the one that was typically here. And A is 33. So it's like ever so close to almost an isosceles. So the first thing I'm noticing without using the formula, right, without using my formula, I can think, all right, 33, I can do it here, or I can swing it around here, and 33 would just be a little bit short of 34. Okay, so if I can understand the picture, this is going to be a two triangle case. All right, but let's go ahead and find this value of h because that's kind of how we determined it, right? We compared the values of h, a, and b. So if I go ahead and calculate h equals, in this case, b sine of a. H equals 34 sine of 47 degrees. All right, let's see where this takes us here. 34 times the sine of 47. All right, so we get h equals 24.866. Oops, not degrees, I'm sorry. Height, that's a distance, a length. But we knew a, right? A was given to us as 33. Okay, and important for this comparison, b is 34. All right, now to confirm this case, and hopefully we do see it, right? When a is between the measures of h and b, when a is between the measures of h and b, right? A is clearly between h and b, then this is where we have the ambiguous case. We're going to have two of the triangles. Okay? So go ahead and leave you to find the actual calculation. I think a lot of you guys do well with the calculation of the law of sines. Okay, this is just kind of determining, the outcomes of it and what it means. Okay, and I think that should be it. Yep, looks good. All right, so hopefully you got some homework assignments. Go ahead and practice those. If you need to take a look back, go ahead, and good luck. Law of sines.